From now on, I'm probably just going to do selected exercises and examples from the textbook because doing lessons is going to take a lot of time and I can only make each video last 15 minutes. So I think just doing examples would probably be really beneficial because one issue that I had while taking the course is that I understood the concepts, but I really needed examples to solidify this. So we're going to start with 2.1 quantifiers, and this is exercise 2.1.1. The answers are in the textbook already provided, but I wanted to go over this one in order to demonstrate the thought process that one has to go through in order to reach the final answer. So the question asks us to analyze the logical forms of the following statements. A. Anybody who has forgiven at least one person is a saint. So what you want to look for are keywords and then to translate them into a logical form. So I see here the word anybody, which is going to translate into the universal quantifier, and we're going to let X stand for a person. So anybody is going to be the same thing as for all X. And the next thing we need to go here is forgiven at least one person. So the at least one person part is that there has to first exist a person, Y. And then there has to be some sort of relationship between them because of this forgiven part here. So there has to be something like F, which stands for forgiven, in which X forgives Y. And then the next part here is a saint. But then remember, like, who is a saint, though? So X is a saint, not Y, like the other person. So we're going to let S of X stand for X is a saint. So that's usually what you want to do in these problems. You want to identify what represents what and like actually write it out. So you want to say let F of X, Y stand for X has forgiven Y. And let S of X stand for X is a saint. I don't have room right here to write that, but when you're doing your homework, like you should write that. So that's what when we put it together, we get for all people X, if there exists a person Y such that X has forgiven Y, then X is a saint. So the reason that we have the conditional statement here is that like here anybody who has forgiven at least one person is a saint. Maybe there's someone that hasn't forgiven at least one person. But also you are only a saint if you have forgiven at least one person. So that's why it's a conditional. So now for the next problem. Nobody in the calculus class is smarter than everybody in the discrete math class. So when you see nobody, you want to automatically think of there does not exist a person X. Because nobody is like, oh, there doesn't exist anyone, or there's no one. And so the next thing you want to kind of find an expression for is in the calculus class. So we can just write that as, like, say, C of X is X is in the calculus class. And now we need to think about smarter, how we can express that relationship. So let's do that as S of xy in which X is smarter than Y. And we want to say, okay, so here everybody, okay, so everybody, it's gonna, it's gonna be a universal quantifier, but it's gonna be a different person that we're referring to, so we're gonna use Y here. And then in the discrete math class, we're gonna represent that as d of y. Okay, so to put it all together and translate it, so nobody, so there does not exist an x, is in the calculus class, so we write c of x, so is smarter than blah, 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 blah. We want to use and here in order to kind of transfer over to the next part, because you have to be in the calculus class and you have to be smarter than everybody in the math class. So now is smarter than everybody. So we want to have everybody listed first. And then they have to be in the discrete math class. So if they're in the discrete math class, then x is smarter than y. So the inside says they're in the calculus class, and for all people in the discrete, if they're in the discrete math class, x who is in the calculus class is smarter than y. So we're saying we attach this not there exists an x on the outside, but to show that there isn't anybody like that. So now for this one, for C, we have everyone likes Mary except Mary herself. So we're gonna let this like part indicate L X Y, which means X likes Y. And then we're referring to a specific person, Mary, here. So we're gonna let that Mary stand for her. And okay. So for everybody here, we're gonna have a for all X. And then we're saying an equivalent way is that if that person isn't Mary, then that person likes Mary. So if that person is not Mary, another way you could write it is if X doesn't equal M, then that person likes Mary. So pretty simple end result, but you have to really think about what each thing kind of represents and an equivalent way to say a similar thing. So for this one, Jane saw a police officer and Roger saw one too. So we have to say, okay, like someone is a police officer. So we're going to represent that as P of X. And then we have to say that they saw them. So we're going to say over here that S means that they saw them. So like X saw Y. So we're going to let J be for Jane and R be for Roger. So, and our X here is referring to a police officer. So someone is a police officer. So Jane saw a police officer. So he's like, there exists a police officer that Jane saw. So there exists an X such that that person is a police officer and Jane saw that X person. And there exists another person such that that person is a police officer and Roger saw them. Oh, sorry. This should be a Y here because we're referring to a different person. Alrighty. So for the next one, Jane saw a police officer and Roger saw him too. So notice the difference here is Roger saw him too. So we're referring to the same police officer here. So we're gonna have to change it up a little bit, but we're gonna use the same notation as we did in part D. So again, instead of having like two parts, we're only just gonna have one part. So there exists a person such that that person is a police officer and Jane saw them and oops. Roger also saw him. Yep, so just gotta keep track of what things represent. Now we have 2.1.6. Are these statements true or false? The universe of discourse is the set of all people, and P of xy means x is a parent of y. So we have to look at each part here and see if it's true or false. So there exists an x such that for all y, P of xy. So this is saying there's someone out there who's a parent of everyone. And so that is going to be false. For part B, it says, for all x, there exists a y such that P of xy. So he's saying that for everybody out there, there's someone who's their child, or like they're a parent of that person. And that is also false because some people don't have children. And part C, there exists an x and there exists a y. Oh, there does not exist an x and there exists a person y such that P of xy. So this is saying, this is very general, like it's saying like there's someone out there such that they don't have a parent. I'm probably not saying that very clearly, but this is going to be false because there is someone out there who does have a parent. Like this is saying that like no one at all like has a parent, which is impossible. So part D, there exists an x such that there does not exist a y, P of xy. And that is true because some people are childless. And for part E, there exists an x and there exists a y such that x is not a parent of y. And that is true. There do exist people out there who are unrelated and not parent and child relationship. So there we have it. I hope that these examples have helped you and make these concepts a little bit easier.